Okay, this is exam 3, physics 101, fall 11. 1,500 kilogram truck must travel a maximum of 22 meters per second around a curve that has radius 52 meters. What is the coefficient of static friction? Well, when we have this truck going around a curve, we have a force. This is the centripetal force, and that centripetal force is provided by the static frictional force. So I can say then that the centripetal force, which is mv squared over r, is equal to the static frictional force, which is mu, the coefficient of static friction, times the normal force, and that normal force is equal to the weight, so it's m times g. So my m's cancel, and I want to know what mu is. So mu is equal to v squared over gr. That is 22 squared over 9.8 times r, which is 52. 22 squared I get 0.95. 0.95, so that's D. When a car travels around a curve, what force provides the centripetal force? Well, just like I said, it's the frictional force between the tires and the road. So that's A. A little boy pushes his sister around on a merry-go-round. It begins at rest, so it means omega naught equals 0. It travels for 12 seconds and is traveling at 3.6 revolutions per second. How many revolutions does the merry-go-round complete in these 12 seconds? So theta is equal to omega naught t plus 1/2 alpha t squared, but I don't know what alpha is. However, I do know that omega equals omega naught plus alpha t. Omega naught is 0, and I know omega and t, so I can figure out what is alpha. So alpha is equal to omega over t. That is 3.6 revolutions per second over 12 seconds. So my angular acceleration is 0.3 revolutions per second squared. And then I can come back over here and plug that in. So omega naught is 0. So theta then is equal to 1/2 alpha, which is 0.3 revolutions per second squared, times my time, which is 12 squared. I get 22 revolutions. 22 revolutions. So the answer for number 3 is D. A sample of blood is placed in a centrifuge, radius 0.15. The mass of red blood cell is that, and the magnitude of the force settles out as that. How many radians per second should the centrifuge be operated? This was identical from the homework. The centripetal force, which is this force that's required to let it settle out of the plasma, the blood cell to settle out, is that. And I know that my centripetal force is equal to mv squared over r. R, I can say that v equals omega times r, and that gives me m omega squared r. So my centripetal force is also equal by making that substitution for v as m omega squared r. And so if I want to solve for omega, which is what I want, omega is equal to fc over mr, the square root of that. And then I put in some numbers here. Fc is 4 times 10 to the minus 11. That's the force required for it to settle out. The mass of the blood cell is given. That's 3 times 10 to the minus 16 kilograms. This is in newtons. And then R is 0.15. If I plug that in, I get 940 radians per second. So that is B for 4. Kaisa sits on the outer rim, Chad sits midway. How do their angular velocities differ? Well, if you have two objects rotating on the same plane, they're like on a merry-go-round in this case, they have the same angular velocity. It's not dependent upon your radius. So they have the same, that is, what is that, an E? Number 5, yeah, E, this one. How many revolutions is 600 degrees? Well, I just say 600 degrees. Simple conversion, 360 degrees in 1 revolution, and that gives me 1.7 revolutions. That's C. An object at rest begins to rotate with constant angular acceleration. If this object rotates to an angle theta in time t, what angle does it rotate in time 2t? Theta is 1/2 alpha t squared. If I double t, that quadruples theta because t is squared. So 7 then is C. What is the net torque acting on the bar about the point C? I just want to add up all my torques. I have 3 forces. I'll call this force 1. The torque provided by this force causes motion in this direction, which is clockwise. So torque 1 is negative. Torque 2 causes motion in this direction, which is counterclockwise. So torque 2 is positive. And then torque 3, the angle here is 90 degrees. Or excuse me, the angle is 0 degrees. This doesn't provide any motion. It provides no torque. So my net torque then is going to be, the sum of all my torques is going to be negative torque 1 plus torque 2. And then torque 1 is going to be 12 newtons times my moment arm, which is 1 meter, times the sine of 30, plus torque 2, which is 25 times this distance, which is 1 meter. So 12 times the sine of 30 is 6, so it's 25 minus 6, which is 19. And since it's positive, it's going to be counterclockwise. So the answer for number 8 then is C. Merry-go-round with a mass of 1,000 kilograms has a radius of 2 meters. Start from rest. Let's just write down what we know. Mass is 1,000 kilograms. Radius is 2 meters. I can go ahead and calculate the moment of inertia. For a disk, it's 1/2 mr squared. That's on that table that you had. That's 1/2 of 1,000 times 4. It's 2,000. It started from rest. Omega naught equals 0. Horizontal force of 50 newtons. Applied tangentially. What is the angular velocity after 2 seconds? T equal 2. I want to know what is omega. I know that omega equals omega naught plus alpha t. I know t, but I don't know alpha. So in order to find alpha, I say that the torque is equal to I alpha. The torque is equal to F times R, which is I times alpha, and I solve for alpha. That's the angular acceleration, FR over I. F is 50. R is 2 meters over I, which is 2,000. It's 100 over 2,000. 0.05. And then I come back over here. I have 0 plus 0.05 times t, which is 2 seconds. So it's 0.1 radians per second. So that's D for number 9. Number 10, a solid matter sphere. Mass and radius given. Spin it at this rate. What is the rotational kinetic energy? Rotational kinetic energy is 1/2 I omega squared. I for a sphere, goodness, is it 2/5? I don't have it right in front of me. I think that's right. We'll see. 2/5 mr squared. That's 2/5 times 12.5 times 1 meter squared. Oh, sorry. That gives me a moment of inertia of 5. And so the rotational kinetic energy is 1/2 times 5 times omega, which is 2 squared. That's 5 times 4 is 20, so it should be 10 joules. Number 10 is B. Following figure shows a configuration of particles arranged on an equilateral triangle whose sides are all 4 meters. Rotation axis is the dashed line in the figure. What is the moment of inertia? So these sides, this is an equilateral triangle, so these sides are all 4 meters. So I know that this distance is 2 meters, and likewise this distance is 2 meters. And so my moment of inertia only arises from these two particles, because this particle is on the rotation axis, so it provides no moment of inertia. I is equal to the sum of mr squared. That is 2 kilograms times 2 meters squared. And then we just double that because we have two particles at the same radius. That's 2 times 4 is 8, is 16. So that's C for number 11. Buckets are spinning horizontally in frictionless bearings. It starts raining. Which of these statements is true? As the mass increases, the moment of inertia increases. The angular momentum stays the same, so the speed decreases. So that's C. Merry-go-round has a mass, 1 meter, spinning at 2 revolutions per second. Then a kid jumps onto the outer rim. What is the angular velocity? So I know that angular momentum initial is equal to angular momentum final. That is I omega initial equals I final omega final. The initial moment of inertia, I initial, is 1/2 mr squared. That's for a disk. That's 1/2 of 100 times 1 squared, which is 50 kilogram meters squared. That's just a disk. All right, so I get 50 kilogram meters squared. It's my initial moment of inertia, times my omega initial, which is 2 revolutions per second, is equal to my I final. And my I final is going to equal 50 plus the moment of inertia provided by the boy jumping on. So that's 50 kilograms plus mr squared. So that's 50 plus the kid was 50 kilograms. The radius is 1 meter. So that's equal to 100. All right, so this is equal to 100 kilogram meter squared times omega final. So omega final equals 1. That's D. Just recap here. Omega initial, that's just the merry-go-round with no kid on it. And omega final, or I final rather, is the merry-go-round with a kid on it. So this is the merry-go-round. That's what we found for I initial. And then this is the moment of inertia of a discrete particle, which in this case happens to be a kid, of a mass 50 kilograms at a distance of 1 meter. Which of these are the basic SI units for torque? Torque is Newton meter. Newtons times meters. That's kilogram meters per second squared times meters, which is that. You want to seesaw with your much smaller 3-year-old nephew? All right, here's your nephew. He sits on the seat. You have to sit there in order to balance to make it easier, so it's closer to the pivot point. That's D. Number 16, 2 spheres of the same mass. One is made of aluminum, the other is made of gold. All right, this is the gold one. They're both solid, so the aluminum one has to be much bigger to have the same mass. So it has more mass distributed at larger radii. Since the moment of inertia is mr squared, the aluminum sphere has the greater moment of inertia. This figure shows a barometer which shows the mercury. The height of the column of mercury is 1,200 millimeters. In units of atmospheres, what is P? See, I don't have the density of mercury. I think it's 2,600 or 2,700 or something like that. I forget. It's like the answer is C. I'll sort of work backwards. All right, so I know that P is equal to rho times G times H. That's going to equal, I think it's 2,700. Is that right? We'll try it. That's 9.8 times h, which is 1.2 meters. So let's see what that gives me. No, that's not right. Hold on. Well, I have to come back to this, or just put in the density. This isn't the right density. You need to put in the density of mercury, and then that will give you the pressure in pascals. It's going to be something times 10 to the 5th. And I'm pretty sure the answer is 1.6. Let me check. Number 17 is C. Yeah, 1.6 times 10 to the 5th pascals, and that's 1.6 atmospheres. Bernoulli's equation is based on which of these laws? Bernoulli's equation is based on the conservation of energy. That's B. In fact, the conservation of energy per unit volume. So that's number 18 is B. Water flows through a pipe at 3 meters per second with a cross-sectional area of a ½ meter squared. Pipe grows wider to 1 meter squared with the speed of water in pipe. So A1V1, equation of continuity, is equal to A2V2. That is 0.5 times 3 is equal to 1 times V2. So that's 1.5 meters per second. Consider this hydraulic lift. What force is required to lift a car with a mass of 1,000 kilograms? Pascal's principle says F1 over A1 equals F2 over A2. Here's A1, there's A2, and the car is 1,000 kilograms, so F2 is 9.8 times 1,000. I want to solve for F1. It's going to be F2 over A2 times A1. F2 is 1,000 times 9.8 divided by A2, which is 1.2, times 0.01. I get 82 newtons. So let's see. Number 20 is C. Consider this section of pipe where it narrows, it goes from left to right. An ideal fluid flows through this pipe. Where's the pressure the highest? Well, we have a low V here and high V here. So that means we have high pressure here and a low pressure here, according to Bernoulli's equation. So number 21 is A. Number 21 is A. Okay, the presence of dark matter was inferred by Vera Rubin by observing the rotation rates of galaxies. Remember, she compared the dynamical mass to the light mass. She compared the rotation rates to get the dynamical mass and the light from stars to get the light mass. Aluminum block has a mass of 1,200 kilograms. What is its volume? Well, we know that density is equal to mass over volume, and so we solve for volume, which is the mass over the density of aluminum. The mass is 1,200 over the density of aluminum, which I don't have. I'm not going to try to venture to guess, but it gives us an answer of 0.44. That density is on your table in your on your equation sheet, which is on Blackboard. Consider this manometer. Which statement best describes the relationship between P and P naught? All right, since this pressure has pushed down and pushed this way up over here, that means that P naught is bigger than P. P naught is bigger than P. Looks like C is the right option. And this is B, of course. Those are the answers.